Good evening, everyone. Myself, Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the NCERT questions. So we have already done most of the questions. So today I am going to discuss the question which was left in this part. Okay. So we have done this 13.7, 13.8, 13.9, 13.10, 13.11, 12. We have already done this. Okay. So let us discuss 13.13 now today. The question they are asking, first of all, read out the question at first so that we can understand what they want. Figure. A figure shows a spring. A figure shows a spring of a force constant K clamped rigidly at one end and mass M attached to it, its free end. So this is the figure and this is the mass and this has been attached to the figure. A force F is applied at the free end and stretches the spring as shown in a figure. Okay, so if app is applied, so definitely this body will come after some time. This body will get displaced by the distance of x. Okay, now in figure 13.21b, so this one we are talking shows the same spring with the both the ends are free and attached to the mass m at the either end, and each end of the spring is stretched by the force F. So here both the side also force is being applied at in this direction, force is being applied at x. But here only one side force is being applied at the at this. It does not mean that in this direction there is a no force. So the reaction force will be equal and opposite reaction force will be applied on this direction. Okay. Now stage. What is the maximum extension of the spring in two cases? So in both the cases, so what is the maximum extension of the spring? So as we know that F is equal to Kx. So x is equal to force by K, that is spring constant, and this is the maximum extension. Maximum extension, okay? So I hope you have understood. Now if we talk about the case 2 we have also x is equal to force by K, because we have only K spring constant and mass M and force is applied is F. So in case A as well as B, both have a same answer. Okay. Now let us go for the next question. If the mass in a figure A and the two masses in a figure B are released, what is the period of oscillation in each case? So they are asking time period of the oscillation. Okay. So the time period of the oscillation for case 1, time period for the case 1 is equal to T is equal to 2 pi root under mass by spring constant. So this is what we have. Okay. But in the case of 2, in the second case, what happened when we apply a force? So what will happen? The amount of displacement this side it will go, the same amount of displacement this will go. For example, total net displacement is x. So x by 2 will be in this direction and x by 2 will be in this direction. So total displacement, maximum displacement will be 2. But at the same time, what will happen? Center of the mass will not change. Okay, center of the mass of the spring will be not change. So finally, it will be assumed, or it can be assumed as this, that there is a separate spring and in this direction there is a separate spring. Okay, and both will have a different frequency or different time period. So this is mass M, this is the force M, and the spring constant will definitely get changed since this is in a series. So spring constant for this second part or each part will be K by 2. So K equivalent is equal to K 2K. 2K, 50% of the spring will have the spring constant of K, a 2k, this one have a 2k spring constant, and this person has a 2k spring constant. Now the time period for the case 2. Time period for the case 2. So the time period for the case 2 is equal to 2 pi root under m by k equivalent. So if we put the value again for a k equivalent, so what we will get, m by 2 into k. So this is the required answer. Okay, I hope you have understood this one. I hope you have understood this one. Now let us go for next question. In the next question, the piston in the cylinder head of a locomotive has a stroke twice the amplitude of that is 1 meter. If the piston moves with the simple harmonic motion with an angular frequency of 20 radian per minute, what is the maximum speed? So let us see the condition. There is a piston cylinder. So this is a cylinder, okay? And there is another, there is a piston. There is a piston in this cylinder, okay? There is a piston in this cylinder, right? There is a piston in the cylinder, and this piston is connected with the wheel like this. So what will happen? This piston will go up and down. So the point about which this will go up and down is this point, midpoint. So the total length is 1 meter. So the about the maximum amplitude will be half of this one, this length, that is 1 by 2 meter. So the amplitude for this question will be half. Amplitude will be equal to 0.5 meter. And they have given omega as a 200 radian per minute. Okay. So we can also convert it into seconds. So this is 200 radian per second, 200 by 60 second. Okay. So I hope you have understood. Now, what is the maximum speed? We know the very important formula for the S.H.M. V maximum for S.H.M. that is simple harmonic motion. A body executes S.H.M. So the maximum velocity, that is V max, will be equal to amplitude into omega. So here amplitude is 0.5 into omega is 200 by 60 second. 60 so this will come as a meter per second. So finally this will 2 3 is 6, 2 10 is this, then so 5 by 3 meter per second. Okay. So I hope you have understood this. So our required answer is velocity max is equal to 5 by 3 meter per second. I hope you have understood this question. Now let us go for question number 13.15. In 13.15, the acceleration due to gravity on the surface of the moon is 1.7 meter per second. What is the time period for the simple pendulum on the surface of the moon if the time period of the surface of the earth is 3.5 meter per second? Consider g as a 9.8 meter per second square. So we have earth as well as, let us consider we have a earth and we have a moon. We have a moon, right? Now the pendulum is same, right? Pendulum is same. There is a pendulum on the earth. So this is earth and this is moon. So there is a pendulum on the earth. Okay. So which has some length, and this pendulum has a time period. The actual time period on the earth. So the time period on the earth for the pendulum is how much? 3.5 meter per second. And the acceleration due to gravity on the earth is 9.8 meter per second square. Okay. Now for a moon. So same pendulum has been kept here, moon also. The length of the pendulum will be same, but the time period for the moon at the moon is how much? So the time period for the moon we want to find. What is the time period of the simple pendulum or on the surface of the moon? So gravity we know that gravity g on the moon is how much? It is 1.7 meter per second square. Now we want time period. Now we know that time period is equal to 2 pi root under L by G. Since 2 pi is constant, 2 pi and L is constant because same pendulum is used, so length of the pendulum will be same. So that's why we can directly say that T is proportional to 1 by G, root under G. Now can we write the formula that time period of the earth divided by time period of the moon is equal to, it is G is inverse, so this will be gravity on the moon divided by root under gravity on the earth. So from here, time period of the in the moon is equal to time period on the earth into gravity on the earth divided by gravity on the moon. So the time period on the earth is 3.5 second into root under GE, that is 9.8. Gravity on the moon is 9.8. Gravity on the earth is 9.8 and gravity on the moon is 1.7. So finally, when we calculate it, so we should definitely get the answer as 3.5 into 2.4. So this will be approximately equal to 8.4 second. So this is the required result what we are searching for as per the question. So I hope you have understood this. So this is a very simple question. Okay. Now let us go for next question. A simple pendulum of a length L and having a bob of a mass M is suspended in the car. A simple pendulum of a length L and having a bob of a mass M is suspended in a car. Okay. And a car is moving on a circular track of a radius R with a uniform speed V. If the perpendicular pendulum makes the small oscillation in a radial direction about its equilibrium position, what will be its time period? Now let us make a car. So let us consider this is a car. This is a car. Okay. This is a car. And it is moving in a circular track. It is moving in a circular track, and the circular track has a radius of R. Circular track has a radius of R. Okay. Radius of R. And the speed with which it is moving is having velocity v. Okay. Simple pendulum of length L. So there is a pendulum. So there is a pendulum which is here. But when it is moving, so what will happen? Pendulum will tend to move outward direction. Okay. So this is the case. A simple pendulum of length L and having a bob of a mass M is suspended. Mass is M. M is the mass of bob. Mass of bob. Bob is suspended in a car. The car is moving on a circular track of a radius R with the uniform speed V. If the pendulum makes a small oscillation in a radial direction about its equilibrium position, what will be its time period? Oscillation. So if oscillation, so they want time period. So we know that time period is equal to 2 pi root under L by G. Okay. Time period is equal to 2 pi root under L by G. Now here what happens when it is moving, so it won't be only a G. So we want net gravity, because when it is moving, so G won't work properly because G is the not only the case. See, when we draw the diagram for the pendulum in this case, so what happens? let us consider there is the pendulum in this case. So this is at this point, okay, and pendulum, if we put the component, so in downward direction the force acting is mg, and in this direction a pseudo force in a circular motion will act, so that is equal to mv square by r. Now net force will act in this direction, so the net force is how much? So if we want net force, so net force will be how much? F net is equal to, since the angle between this is 90 degrees, so this will be a square. If it is a, if it is b, so a square plus b square plus 2ab cos 90 degree. So this will become 0 for f square. So f net is equal to what? F net is equal to what? So this will be mg whole square plus mv square by r whole square. So what is F net? F net is equal to mass into G effective. So this mass M, this is mass M only we are talking about. So this is mass into G effective. If we will get G effective, so then only we will able to figure out this M square plus V square by R whole square. So M square, it will get cancelled out. Okay. So we want G effective whole square. So G effective whole square is equal to this. Okay. Now if we want G effective whole square, so G effective is equal to what? Root under G square plus B square by R. So we need to put here. So here we need to put the G effective. So time period is equal to G effective. Let us put here 2 pi root under L by G effective is how much? G square plus B square by R. So this is the time period. So our result, this is the required result for, this is the required result. So this is the case. I hope you have understood this case. Okay. So this is question number 13.616. So we have done this completely. Now let us go for a next question. Now first of all, read the question. A cylindrical piece of the cork of a density of a base area A and a height h floats on a liquid of a density rho L, and the cork is depressed slightly and then released, so that the cork oscillates up and down in S.H.M with the time period of t. So basically the condition is that there is a cork, cylindrical cork, okay, and it has been immersed in the water or a liquid. So let us consider there is a liquid. Let us consider there is a liquid at this level, okay, and the cylinder has a height. Let us put the values of the height. So height of the cylinder is h, okay, and rho is the density of the cork, and rho L is the density of the liquid, right? Now it is in equilibrium position. Now let us consider this length as a k length, okay. Now it is at equilibrium. It is at equilibrium, okay. So if it is at equilibrium, and let us consider this is as a area is equal to A, okay, and this is the equilibrium condition. So it is an equilibrium. It means that the gravitational force, the force acting downward, gravitational force mg will be equal to point force fb. So finally we can write here point force is equal to mg. Now, what is point force? Point force is equal to, we know that point force is equal to weight of the liquid displaced. So how much weight of the liquid is displaced? So we need to find the volume of this, and we have to take the mass and the gravity. So how you will find the buoyancy force? So point force is equal to area into h, that is volume. Force is equal to mass into gravity, but mass of the liquid displaced. So here mass of the liquid will be equal to volume of this portion. So volume of this portion, so mass per unit volume is equal to density. So mass is equal to volume into density. So volume is equal to area of the cylinder into height. So what height we have to take? K. K into area into K. So we have got the volume into density of the liquid into G. So this is, and this is equal to mg. So this is the one of the condition we have got, right? Point force. Got it? When it is in equilibrium. Now let us do one thing. If we apply a force, see here in question they have written that if we apply a force, see here, uploads a liquid of a density, the cork is depressed slightly. When it is being depressed slightly, so let us consider this cork come inside it. So what will happen? The new position will be this. So when it will come go down, so what will happen? And when you leave it, so it will come up and down, and it will create an S.H.M, right? It will create an S.H.M. What we want to find? We want to find time period for S.H.M. So time period is equal to 2 pi root under, time period is equal to 2 pi root under m by k. M by k. Got it? Now see here. Mass of the this body or cork is given, right? Now we need to find k. So when I will move this in this direction, so what will happen? There will be an extra displacement of x here. There is an extra displacement of x will be there. Okay. Now when there will be an extra displacement of the x, so what we will get? So net raised to see here. When I will push this, so what will happen? There will be net restoring force which will act upward direction. So how we will find net restoring force? So F restoring force will be equal to point force minus mg. Okay, because net restoring force will act on a upward direction. So buoyant force will be more. So buoyant force can be written now as a, how you will write buoyant force as here? See here. Now the earlier buoyant force was A into K into rho L into G. Okay. Now here what we can do, area is okay, same. K, that is distance, is not K now, it will become K plus X into rho into L into G. So if we and into minus Z. So if we calculate it properly, so this will be AK rho L into G plus AX rho L into G minus mg. Now AK rho Lg, so AK rho Lg is equal to mg. So we can put here mg plus area into x into rho L into G minus mg. So this will get cancelled out. So this is F restoring force. So due to restoring force, we have F restoring means what? It will create a S.H.M. So app restoring. So if for a S.H.M. equation, we know that app is proportional to x. So app is equal to kx. Okay, f is equal to kx. So here we have to put here x, kx. So this will be kx. F is proportional to kx. So here we have to put here k into x, and this is equal to area into x into rho L into G. So we can cut this x. So we have got k. So k is equal to area into rho L into G. Now we have got k. Okay. Now we have got k. So we can put here to find out time period, we have to put the value. So we can put here the values for the time period. So time period will be equal to 2 pi root under m by k. So m by k is area into rho liquid into gravity. Now mass of this body. So mass of this body can also be written as mass is equal to volume into density. So volume is equal to area into height h into density is how much? Rho divided by area into density of the liquid into G. So when we cut this area, so finally our time period will be equal to 2 pi root under h rho by rho liquid into G. So this is our desired result. So from here we can see that we have T is equal to 2 pi root under h rho by Lg, and we have got the same answer or a same result. So I hope you have understood this question in a proper way. Okay. Now let us go for a question number 13.8. So in the question number 13.8, we have to go one by one. One end of the U-tube containing a mercury is connected to a suction pump. And one end of the U-tube containing mercury is connected to a suction pump and the other end to the atmosphere. A small pressure difference is maintained between the two columns, shows that when the suction pump is removed, then the column of the mercury on the U-tube execute a simple harmonic motion. We need to find so that it execute a simple harmonic motion. See here, let us draw the condition. There is a U-tube. So this is your U-tube. This is our U-tube, right? This is the structure of U-tube. Okay. And there is a suction pump. There is a suction pump, right? So this is a suction pump from which it will suck. That it will try to suck the liquid. So the liquid which it will try to suck in such a way that, see here, the liquid will come in this level, and it will also go in this level. See here, got it? So this is the case. Now when it will release, so what will happen at the what will happen? See, this is the condition. See, it is when it is in without suction. So what will happen? Without, if there will be no suction, then what will happen? The liquid level will come like this. Okay. Liquid level will come like this. So this will be the liquid level. But now the thing is this, that when we release it, so liquid will come down, and due to inertia it will go up, and this will continue, and it will create an S.H.M. So how you will find the S.H.M of this thing? Let us consider the height of this liquid as this. Total height as average height is h. Okay, and if you think that this is very small distance, so this is a height h. Now what happens? What happened when liquid was in this condition? So it was rising at the height of x. So let us consider this was x, and when it come down, so what will happen in this area? It will rise up for x, and this will rise down for x. So this will come down. So total displacement will be total distance will be 2x. Okay, total displacement will be 2x, and it will move up and down about this position, and due to which there will be an S.H.M. Okay, now we need to find restoring force, because if there will be a restoring force, from there only we can find the value of k, and from there we can find the time period. So the restoring force is equal to what? It will be F restoring force. How we will find F restoring force? See, F restoring force means this amount of liquid. This amount of liquid is responsible for the movement. So weight of this liquid will be equal to mass of this liquid into g. So mass of this liquid is equal to density into gravity into volume. So volume will be, let us consider this is an area A. So area A, so this will be area into volume is 2x. So this will become a restoring force. Okay. So F restoring force, we have got F restoring force. From here we need to find a K. So how you will find a K? So F restoring force is equal to Kx. So X is common. So we can easily say that K, value of K will be equal to, K constant will be equal to rho G A, 2 rho G A. It will be 2 rho G A. Okay. It will be 2 rho G A. I hope you have understood now. K, value of K is 2 rho G A. Okay. So this mass is responsible, restoring force is responsible for S.H.M. Now, what is the mass of the liquid to which it will be pushed? For example, if we think that there is a spring and there is an external mass, and we have to apply a force or restoring force to move up and down to create an S.H.M. So we have to use this mass so that our time period will be equal to 2 pi root under 2 pi root under m by k. Okay, 2 pi root under m by k. We have got here k. Now we need to find a mass. So mass of the whole body which is responsible. So let us consider whole liquid mass. Mass of the whole liquid is equal to volume into density. So the density is same. So volume will be area into height. So the total height is how much? See here. One side liquid column has height h, and another side liquid column has height h. So 2h. So area into 2h into rho. So this is the mass. Now we need to put the values of mass as well as k. So the time period will be equal to 2 pi root under mass is 2 into area into h into rho by k has a value 2 rho g into a. So a got cancelled, 2 got cancelled, rho got cancelled. So finally the time period is equal to 2 pi root under h by g. So we have got the required result. So this is the example of S.H.M. Whenever you will find any restoring force, then it means that there is an S.H.M will be created. Okay. So this is the time period for an S.H.M. I hope you have understood this question properly. If you have any doubt, so please ping me in the comment section so that I can resolve that question. I hope you all have understood this. Thank you for watching my video. Thank you, everyone.